This, if there is no non-conservative force, there is no heat generated. The change in energy in mechanical has to be equal to what? 0. So it means that the whole potential energy, which is mechanical, has to transform to what? At this point, what will be? At this point, what will be? Half and half, let's say kinetic and potential. And at this point, kinetic and potential, but hitting the ground, what will be? Kinetic. So at the end, it's also the law of conservation of energy, because we don't have heat, but we will say law of conservation of mechanical energy, which means that the energy cannot be created nor destroyed, right? Which is what you learn from a kid. Energy not created, not destroyed. This is what we have here in the theory. So summarizing energy, which is how to use it. This, the first theorem, we already used it. And W net is equal to delta K. We use it when forces are given explicitly. The second theorem, which is this, is WNC is equal to delta K plus delta U, which is the change in mechanical energy, E final minus E initial. When we will use it usually? When the forces not necessarily are given. And number 3, EI is equally final, or delta U, delta E equals 0, when there is no non-conservative force. These are the 3 important elements to decide which theorem we will use at a certain point and which one we will use. For example, now that we know the 3 theorems, let's say that we have this object which has a mass of 10 kilograms. It's falling to the ground, where the ground is 3 meters. So Y initial is 3 meters from the ground. Find Y final at 2 meters and find Y final, another one. Let's say that this is Y2, Y3, Y1. When it's 0, what we will find? The velocity. We can find the velocity using energy. We can find the velocity here at 2, and we can find the velocity at 3 using energy. Is this object? The first question, when you are dealing with energy, you have to understand that we will use one of these 3 theorems, the more convenient, according to this information that I said here. The first thing you need to think is which of the 3 theorems I will use if I use energy. I could use free fall. Are you agree that we learn this in free fall? How to get this in free fall? But I want to use energy now, because energy is more general. If I said this go to the ground like this, and I don't mention air resistance, which of the 3 theorems? Did I say anything about forces? Any force is given explicitly here. This, what's said here? Forces are given explicitly. It's ruled out. Then we go to the second. In the second, what did I say? The work done by the non-conservative force, the forces are not given explicitly. And of course, we have to have non-conservative force. Do we have non-conservative force in this problem? No. I didn't say anything about friction. So what is the only one that left? The third. That's your choice. This is what you have, the way you have to think. So it's the third choice. You start writing the formula for the third choice. EI is equally final. And now you become an inspector of energy. Put the hat, you say, oh, I am energy inspector. And you say, oh, what is the energy and what type of energy have the object at this point? Because I know that EI is equal to E5, no? I know that this is the summation of kinetic plus potential at the initial moment. Is that right? Because that's the definition of mechanical energy. So, and now I inspect. Does the object have kinetic energy at the beginning?
No.
No. What do you see? What you do for this guy? So we are going from 1 to 2. This is the second point, and this is the third. I am now in the second. Second point, third. I am in the second. I want to find the velocity at 2. So what can I do? What can I do? What is K initial at the beginning? 0. I put 0. Plus, again, I am an inspector of energy. I inspect what type of energy. Does this object have potential energy at this moment? And what type? The spring or gravitational? Gravitational. I don't see any spring. This is not a, how it's called, when you jump. When you jump, like this, when you were a kid, and trampoline, this is not a trampoline that has spring and elasticity, it's just in the air. So there is no spring, it's only gravitational. So, and what is the formula for gravitational potential energy? mgy at that moment. How much is y at this moment, at moment 1? 3. Do you have the mass? Do you have the gravity? 9.8, not negative 9.8, we are using magnitude. And we have this, equal. Now we go to this moment. At this moment, the object has kinetic energy. Look, tell me if it has kinetic energy. What is kinetic energy by definition? Energy due to motion. Tell me if this has kinetic energy at this moment. That has? Okay, what will be the formula? Go to the formula of kinetic energy there. 1/2 mv squared. We write 1/2 mv squared at what point? At what point we are looking for the velocity? Second point, V2. Plus, does the object have altitude at that moment? And what is the formula? You see, white is easier than to work with the big 3 equation of kinematics. Who doesn't know that the kinetic energy is the energy due to the motion? And the formula, you just have to know. But if you don't know, you have the formula, 1/2 mv squared. But this, you will see everywhere in chemistry, in physics. 1/2 mv squared. The big 3, you only see in physics. And who doesn't know this formula? MGY, MGH. You will see that formula everywhere. And you just need to know that the mechanical energy is the addition of both, kinetic and potential at a certain point. You just write this, and then you know that is the addition of both, and then you find by inspection if it has or not. And now, look, the mass. What happened to the mass? If I am looking for V2, so what do? I move this to the side, I get 1/2 V squared, V2 squared equal to G Y1, and I subtract Y2 to the other side. And then what I have to do? I multiply by 2 both sides, right? And now what do? I find the square root. But if you look at this formula, V2 squared, and if I put V1 squared, if I put it here, plus, but what is V1? In this case, what is B1? And what is this formula? What is this formula? The third one of the big three. And will be negative. Negative G will be here, but why negative G will be here? What is higher? So this is Y1, and this is Y2. Now, because I am getting the magnitude here, this is 0, and this is plus, because it's going down, the gravity will be, so we have this is final minus initial, sorry. Y2 minus Y1, right? Which one is greater between Y1 and Y2? Y1. So this will be negative, and when I put the negative here, what is this? Yeah, but what is that? Where did you see that before?